Hi and thank you for viewing. My name is Brian, and today we are going to configure a very basic company network, using VLSM, VLANs, DHCP, as well as routing on a stick. This will be the first in a series of videos where we will be building off of this basic configuration using more sophisticated network concepts. For ease of demonstration, we will build these networks using Cisco's Packet Tracer program, which is free for download at cisco.com. Requirements for this network are 6 departmental VLANs with varying numbers of users per VLAN. Inter-VLAN communication. All VLANs except the data center VLAN will use DHCP. Define an IP address on the SVI interface used on the switch. Define the sub-interfaces on the router used to route traffic between VLANs. Define a block of IP addresses to be used in the future for WAN links. Here is the step-by-step process used to design the IP address scheme that we will use for the corporate office network, using the private 10.0.0.0 Class A addresses. I use the lower IP addresses for nodes, and the higher IP range addresses for WAN links, so that network types can easily be distinguished. Step 1. Determine the number of subnets required. 6 corporate LANs. 20 WAN link subnets using /30. In total, we need 26 subnets. Step 2. Determine the number of host addresses required for each subnet. Step 3. Determining the subnet mask for each subnet. For the first LAN, we need at least 1400 usable IP addresses. The closest power of 2 to 1400 is 2048, 2 to the power of 11, which requires 11 host bits. The subnet mask for this subnet is therefore /21, 32 minus 21 equals 11. For the second LAN, we need at least 400 usable IP addresses. The closest power of 2 to 400 is 512, 2 to the power of 9, which requires 9 host bits. The subnet mask for this subnet is therefore /23, 32 minus 23 equals 9. For the third and fourth LANs, we need at least 50 usable IP addresses each. The closest power of 2 to 50 is 64, 2 to the power of 6, which requires 6 host bits. The subnet mask for these subnets is therefore /26, 32 minus 26 equals 6. For the fifth and sixth LANs, we need at least 200 usable IP addresses each. The closest power of 2 to 200 is 256, 2 to the power of 8, which requires 8 host bits. The subnet mask for these subnets is therefore /24, 32 minus 24 equals 8. For the WAN link subnets, we are using /30, which provides 2 usable IP addresses per subnet. Here is what it looks like, all filled out on a spreadsheet. Now on to the fun stuff. In Cisco's Packet Tracer, I have already created these shaded boxes to represent the VLANs that we will use. Add the router. Add the switch. Add 2 nodes per VLAN. Next we will cable the devices together. If you haven't used Cisco's Packet Tracer program, I highly suggest you do. It's great for practice and proof of concept. And finally the switch to the router. Time to configure the switch. Let's change the host name. I like to turn off IP domain lookup. This turns off accidental lookups if you mistype a command. Next we add the VLANs to the switch configuration. Assign the switch interfaces to the correct VLANs and turn them up. Now verify the VLAN configuration. Correct any mistakes, if found. Now run the Show Interface Status command to see that all connected interfaces are up. Let's check the IP scheme and add the SVI interfaces for the VLANs. For now, we are only using the switched virtual interfaces for testing connectivity. We could use them to route the traffic more effectively, rather than use the router on a stick. But for this exercise, we are going to ping them across the router link to make sure we can communicate. Let's check the IP interfaces for any errors using the Show IP Interface Brief command. Let's change preferences in Packet Tracer so we can see the port labels and what port the router is connected to the switch. Gig 01 on the switch needs to be set up as a trunk port. When we get to the router configuration, you will see why. Make sure to no shut the port to bring it up logically. One more check of the interface configuration. Now, on to the router configuration. First, let's change the hostname, and once again turn off IP domain lookup. Next, we no shut the main interface gigabit 0/0. Now we start building the subinterfaces that will communicate with the trunk we configured on the switch. These will end up being the default gateways for the nodes in the VLANs. The gateway addressed can be found on the IP worksheet. Let's check our subinterfaces with the show IP interface brief command. Now let's try and ping the SVI interfaces on the switch to verify we have connectivity. First few packets will time out until the ARP requests are complete, and an entry for the switch interface is put into the ARP table. Good, all of the interfaces responded to the ping requests we did. When we look at Packet Tracer, it is showing all links green. Let's build the DHCP exclusion list. We need to make sure that DHCP does not give out the IP addresses we have already used for the SVI interface on the switch and the gateway address on the router. Next we build the 5 DHCP pools for all of the VLANs except the data center VLAN 16. The reason we are not using DHCP for the data center is the data center equipment, like file servers and mail servers, should have their IPs hard-coded so we can easily track them. For all of the DHCP options, check out RFC 2131. I'm going to use a little copy and paste to speed up the process. It is good practice to have your configuration in a text file and copy and paste in sections. It helps prevent fat fingering the commands as well as speeding up the process. I ran a quick show run on the DHCP section to confirm the configuration looks good. Let's save the configurations using the write mem command. You can also use copy, running config, startup config, but I prefer the shorter command. All that is left is to set the PCs and laptops to use DHCP, and do a few connectivity tests. It's showing successful DHCP requests. That is a good sign. Now let's ping a few gateway addresses from the nodes, and then try and ping nodes on another VLAN, and run a trace route to that same node. Ping gateway, check. Ping node on another VLAN, check. Trace route to the node on the other VLAN, check. Time to recap. 1. Define network requirements. 2. Build logical subnets based on requirements. 3. Define network addresses to be used as gateway or other network interfaces. 4. Define VLANs and determine what nodes will belong to them. 5. Configure equipment with VLANs, interfaces, IP addresses and any other services like DHCP. 6. Test configuration. 7. And, always, document. Please give a like and subscribe so you will be notified when more videos are added. Thank you for watching and have a great day.